Hi everyone, Milda here. I hope you are doing fine. This is the first tutorial of a series of tutorials that have as an objective to make data science, statistics, and probably other adjacent fields of expertise accessible to all. Data science is not supposed to be some kind of elite science. Maybe it inherited that from mathematics. I believe that we can all together debunk this myth and make all these elite sciences simplified and easy to beginners, learners, and professionals. These tutorials will be quick and focused, I promise you. We don't have time to splurge into irrelevant details, so let's get started. This tutorial is about R. How to get R? Why R? R is an open source statistical tool. It is used by a wide variety of professionals, mathematicians, statisticians, econometricians, biostatisticians, also then people are working with the geographical information system. The advantage of open source solutions as R and also Python that we are going to see in other tutorials is that there is a wide community of users that are supporting this system or this project. Second, whenever you are stuck at something, you get help from other users, peer users, people like me and you. Also, you can contribute to this project if you are good at coding and you get confidence, or if you see a procedure that you invented from your research as a mathematician or a statistician, you can code it, put it into code, and make it available to other users to benefit from it. Or if you are like a simple coder, you are not an advanced mathematician theory. You are not advanced in theory. You can, if you find a very good paper or a very good piece of work, you can code it and make it accessible to others to benefit from. Also, there is something that I want to clarify to people. For example, it may be like a genuine question for someone going to companies or big companies. They don't use much open source solutions. They are like investing in other expensive statistical packages like SAS or Stata or EViews. The question here is about quality control or the quality of the results of the statistical procedures. These companies guarantee to the industry some high standards. They guarantee that this statistical procedure is of good quality. They assume this responsibility. Whether in open solutions, in open source solutions, the companies have to make like some standard procedures to control the results, quality of the results. So if you are like some kind of researcher and you want some good quality work, this is a piece of advice. Please go into every statistical package here, go and review the code so you can test it and retest it so you can be sure of the quality of your results. But before all of this, you are a new user to R. How do I get R? It's easy. You go directly to Google. You can go ahead and type the two magical keywords download R. You have to download R. I advise you to download it from the official website, which is rproject.org. You can find here in this web page a lot of resources like if you wanna know what's new in R. If you wanna get the news, if you are a developer, if you wanna be part or contribute to the foundation of R, etc., or get the help, get manuals, etc., we can go ahead and download R here. Here are the current mirrors, people that are giving in mirrors, repositories to store R in, so it can be accessible to people around the globe. I will choose, for example, the first zero code. So depending on your operating system, Linux, Mac, or Windows R, you can install R to your system. So you can get the files here by clicking on these on some of the links. I'm very fond. Um, I love Linux, but in my system here in this computer, I'm using Windows. You can click here on Windows and get install R for the first time, and you can find here the latest version, also available for both the architecture 32 or 64-bit. And go ahead and download it and launch. It's only 80 mega, etc. For the installation, it's pretty intuitive. You can go ahead and follow the instructions from the wizard of the installation. Choose your language, choose where you wanna store your files, etc. And the same also for people who are very familiar with Linux. You can install it either from the command line. We can, if you want me to show you how to install R from for Linux, you can drop me a comment and I will do this tutorial for you. So this is the R. This is the interface. This is not a very convenient interface if you don't have time to spend on coding, but I want you to spend time on coding. There is another version of R which is more beautiful. This is the R Studio. Most of the procedure you can just click on these procedures, but at the same time, if you code here, develop a script here for R, you can run it on the R Studio, and vice versa. Here you can find the many, what we call these, I don't know. From this console you can run the commands, but I prefer here to create like a new script. You can do a lot of things with R. For example, let's do the first simple things. It's like declaring variables. R is built on C. So, but declaring variable is a bit different. It's not like we are declaring the type of the variable before giving it a value. Here in R, R learns the type of the variable by reading it, by reading the content of the value of the variable. Let's give you an example. So here, for example, y give it 14. So here in y, the value 14 is stored in the variable y. It is also important to note that R is sensitive to lowercase and uppercase. For example, uppercase y gives it another value which is 2 point, for example, 2.6. It's two different variables. We can perform here the multiplication, the simple multiplication of lowercase y and uppercase y. We can here see the type of y. It's double type of big Y, which is double. Math operation that can be performed with R as all the types of mathematical operation that we can run pretty much on the CMD, on the command line. You can run them in here. You can run advanced mathematical operations, especially those that we are going to need in statistics, which are algebra operations. In R, we can create vectors. For example, let's create a vector t. The equal sign means you assign the value which is in the right hand to the variable which is in the left hand. For example, t, using the function c, you can create the content of your vector. Let's do something here. Let's give it something. For example, you can separate the components of your vector by commas. We can build a vector of size 3, for example, 4, 7, no, 7. Go ahead, we can create another vector, u, c, let's get crazy a little bit. Create a fraction here, a decimal. Type of operation that we are going to do, for example, let's transpose t. Let's call it t. It is the transpose. You can use the function t to transpose t. We can create a matrix from these two vectors. For example, this is our first matrix. You can use a function if you wanna take these two vectors and put each one on a row. You use the row bind. It's R bind with T and Q. You can create another matrix by making each one of these vectors in a column. It's a column bind matrix. For example, T column bind with T and Q. We can do. Let's run these commands first. So let's see how how to run the script. Here you select the lines of the code that you are going to run, and you click on this line here. I didn't read T. I forgot to read T. So we can go ahead and see how it's gonna transpose T. We can view T just by selecting T and pasting it into the console. Let's see our matrix, our first matrix, which is a bind of rows. You can see it here. Each vector here is on each row, and here are the names of the vectors. We can go to the matrix column. We can visualize the matrix with column. Each vector here is on the column. Go ahead and do some mathematical operations. Let's do the product. For example, T multiplied by U. T double multiplied by U. You have to make a difference. R here make a difference between the product. When you are doubling the sign of the product, it's gonna treat this product as a matrix. One side of product is gonna be treated as a multiplication of each component with its correspondent component in the other vector. We can see both of them here. They are pretty much identical. It's see, for example, if we do products between matrix and matrix lowercase c, it's all experimenting. These are how we learn about the R. It's by experimenting. Here, the size of the multiplication is not correct, and we know it. So here the error say that this product is not possible mathematically. Can you transpose here? See if it's gonna correct the problem of the sizes. Yes, it did. As a matter of fact, so we see here the products are kind of different. The first product is one component multiplied by the other. The other one is the matricial product as we know it, the row multiplied by the column with the sum. The next time we're gonna talk about how to create functions, how to create loops and conditionals. Also, I will lay some principles of algebra that we are very important, that are really very important to understand statistical optimization and inference. Thank you for all your attention and looking forward to see you next time. Bye bye.